Okay, analyze the function log x minus 2. Okay, so you're going to use your calculator. In the y equals 2, type in log x minus 2. Let's look at this graph. You guys have it graphed, right? Yeah. Okay, your graph probably looks something like this. Is that the correct graph? You have no idea. Okay, remember the 12 parent function. We said log x graph, that's the parent function. Log x graph looks like what? Yeah, pick the ball from the bottom, throw it, right? So actually your calculator is not showing you the entire graph. It goes down forever. So every year when I ask someone to analyze, someone will always tell me range starts here to infinity. No, all real numbers. The range is all real numbers.
What? You mean domain or range?
The range. The range is all the way down, and then it is actually going up just very slowly.
Why is it
So it doesn't stop at 1.
It says undefined because it's actually trying to go to the left of it.
Oh,
Yeah.
So like it's not undefined or undefined.
No. Okay, so your calculator, what happens to your calculator is when you are here, you get a number. And then when you press the left button, it's not going down, it's going this way.
oh okay.
So then it's like, oh, there's no number. Yeah.
I meant at the top because you said it's slowly going up. It doesn't like.
Oh, there's no horizontal asymptote, is that what you're saying?
Yeah.
Yeah, there's no horizontal asymptote. But on this graph, there is a vertical asymptote. So this is where you need to memorize the graph instead of looking at just the calculator because the calculator is not entirely correct. Desmos is not much better. It will also stop. I don't know why it is. It's the way they wrote the program. So if you are a computer person, you can work for TI.
Another complaint to add.
Okay, so goes down forever, goes up forever. Just it goes up slowly. All right, so go ahead and analyze this graph. Let's start with Murphy. Domain.
F is bigger or equal to 2?
Yes, bigger, not equal to 2. We cannot equal to 2. So all of the logs have an asymptote. So it's not equal to 2. 2 to infinity. Raymond Kim, range. All real numbers. Daniel, continuity.
Always continue.
So continuous. Okay, Philip, increasing?
2
Yeah, 2 to infinity. Jingyi, decreasing? None. Wimble, boundedness?
No.
None. Okay, you can tell that it's not bounded because the range is all real numbers, okay? Jingzi, extrema?
No.
None. Okay, you can only have extrema if it goes up and down. If it's always increasing, then it's never gonna go down, so no extrema. Gary, symmetry? Neither. Elizabeth, asymptote?
X equals 2.
X equals 2. Okay, Shauna, give me one and behavior.
X to the limit positive limit fx to the positive limit.
Yes. When x goes to infinity, y goes to infinity. The other one is a little bit tricky. X doesn't go to negative infinity. It stops at 2. So x is going to go to 2. And then y goes to negative infinity. Okay? You cannot go to negative infinity. There's nothing past 2. Okay, tomorrow we're going to do the inverse and do some transformation. We're on page 9. Okay, so we didn't finish the analysis yesterday for the second one. Page 9. All right, so the question is, what is the inverse function of this function we were doing yesterday? So this is the function. What is the inverse function of that? How do you find the inverse function?
You switch.
Switch x and y, good. Okay, so let's write this down. So the original function is y equals log x minus 2. So switch x and y. X is equal to log y minus 2. Okay, now we need to solve for y. How do we solve for y?
Subtract.
Ooh, cannot subtract. It's stuck. Oh, you're gonna divide by log? No. Natural log, no.
Add a 10.
Yeah. Raise both sides by 10. Okay. Raise both sides by 10. All right. 10 to the x is equal to y minus 2. Now what?
You just add the 2.
Add 2. Okay. Y equals 10 to the x plus 2. Okay. Now go ahead and do the analysis. A lot of it you can actually get without graphing because the original graph and the inverse graph are always inverse of each other, meaning the domain and range switches, meaning everything switches. Like you just kind of swap. Okay, so you could do the analysis without graphing, but go ahead and graph it and do the analysis, and then we'll go over it together. Okay, let's start from the middle. Okay, so Jinzi, can you give me the domain?
Or real numbers.
Sophie, range? 2, infinity. So domain and range switches. Gary, continuity. Continuous. Elizabeth, increasing.
Negative infinity to.
To what?
2.
No, infinity.
Infinity?
Yeah.
Okay.
Negative infinity to infinity. Decreasing, Shauna.
No.
None. Does someone have a question about increasing?
Is it one? Yeah, but is it constant like the amplitude? Because
Okay. All right. So the log graph look like this. When you flip it over for inverse, it looks like this. The original graph has an asymptote at x equals 2. The inverse graph has a horizontal asymptote at y equals 2. So x and y switches, not, I don't know how to say it, not like left and right and up and down. It's flipping over the x at y equals x. Okay, Sunny, but boundedness. Yeah, bounded below.
yeah, below.
Right, because e to the x always has a lower bound. This one is just going to be bounded at 2. Bruno, extrema. None. Lisa, symmetry. None. So neither. Murphy, asymptote. Yes, the only asymptote. Raymond K, and behavior.
Limit x goes infinity, f is
And then Daniel, give me the next, the other end behavior.
That's x to the negative infinity. Y goes to 2.
Yes. Okay, y stops at the horizontal asymptote. Any questions? Yeah. Boundedness. Boundedness means that you cannot go above or below or whatever the bound is. It says there's a lower bound, meaning this graph has a lower value, which is at y equals 2. It's not going to go below.
So what about the original function?
Original function? Original function is this way. So there's no bound. It keeps going down. It keeps going up. It just can't go to the left, but we don't care about left and right. Boundedness has to do with y direction. Okay, next part. Are you guys good? Okay, so this kind of question will come up on the test, just warning you. So A lot of you didn't do so well on the last test because you kind of only study the things that we kept going over and over, not everything in the notes. So anything in the notes could be on the test. So make sure you read your notes like at least once before the test so you can at least have some memory of what's going on, even the obscure ones. Okay? All right. Next part. This is very easy. Transformation, we kind of have to do that for every parent function. Okay, f of x equals. What do we always start with on our transformation?
11, right?
The equation, sorry. A. Okay, and then what is the parent function for logs? Log. Okay, and then let's just say it's base b, so just any base. And then what do we have? X, good, but this time we have an over C because now we are better and wiser in our second year of doing this. We have horizontal stuff. And then what's going to happen after that? Minus
K.
H. And then plus K. All right, really quick. Let's have you guys do 1, 2, 3, 4. Identify the transformations. Let's start with Philip. Number 1. Left 2. Okay, Jingy, you get the hard one. Reflect y-axis and then not left 3, right 3. So the order matters on this one. If you flip over at y-axis first, then you have to go right. If you want to go left first, you can go left first and then flip over y-axis. Daniel, you can keep drinking your water. He's like, what?
So
if you,
If I wrote 3 right and reflect by y, it's going to be 1 because of the order.
correct. The graph is like this. It is right 3. So,
Wait, so which way can you do it? Yeah.
okay, you can do reflect y-axis first and then right 3, or you can go left 3 first and then reflect y-axis.
Oh, okay, cool.
Okay, Wimble, number 3.
Vertical stretch by 3.
Good. Peter, number 4. Good.